today, the 16th December 2021, I would like to explain the principles on which our new experiment is being based. First, this is the circular cathode ray tube. This is the amplifier with which we experimentally would like to try to activate or driving the circular deflection magnets. That means here are coils involved. This here is the so-called ladder network, which we will explain on our website. It actually is causing a phase shift between here the input and here the output. The output, so the signal here, we consider it 0, and this being phase shifted 90 degrees. Signal being fed onto this amplifier. We have, or we use an amplifier with more power or energy, because we do not know exactly the amount of energy we should put into this deflection system. You may consider that the sensitivity or the working energy is known. It isn't, because we in Nachtfee operate with 500 Hertz as a PRF. So the repetition frequency is 500 Hertz. But the Nachtfee deflection inside the Nachtfee console is having an induction of circa 100. And the deflection coils here are possessing only 50 millihenry. So it's about 20 times that value. And because it originates not from a Nachtfee, but from an aircraft a radar system, a German one, by the way, and that is operating often with frequencies about 2,700, 2,900 Hertz. So the operating frequency is much higher. And what I would like to show you is the situation here, and I would like to focus more on it. Let us now have a look at the amplitude of this 500 Hertz sine wave signal. And I will now change the frequency from 500 Hertz to 1000 Hertz. And you will see there is, of course, an increasing amplitude, but not that much. We are measuring now on the channel which is being phase shifted. And a phase shifting network or ladder network is causing an amplitude reduction because it is also a resisting influenced network with coupling capacitors, and the C and the R are versus frequency shifting some phase. Now I would like to go to 2000 Hertz. And you will see also an increasing amplitude, but still it isn't very much increasing. And finally our experiments later will operate maximally with 3000 Hertz. And again, you will notice an increase of amplitude, or hardly an increasing amplitude. But this is for us a precondition of what we are doing. The other test we will do later is making the oscilloscope, but that is a business of Hans. He will work on getting the cathode ray tube operating. And the only thing I would like to show you is the way the display, wait a minute, the display is, well, let me save. Visible. You see, it is not the normal deflection system, but it's a circular cathode ray display, and by means of one signal direct, so it's a 0 phase shift and 90 degrees phase shift, and if the amplitudes are equal, it will paint a first order Lissajous figure on the screen, which is in our case a circle. And that is the means of our experiments for today. Thank you.